Section 1.4 is all about sketching graphs. Here are some vocabulary words that we've already discussed that will still be used. Domain will be your x values, range will be your y values, intercepts are going to be where your graph crosses your x or your y axis. We decided to not talk about symmetry, so you can ignore that piece. End behavior are going to be your tails, which way are those end tails going to face. Extrema is going to be your minimums, your maximums, your relative mins, relative max. Increasing and decreasing is going to show which way your graph is going. So as I go from left to right, is it going up or going down? Positive or negative is going to be where your graph is above or below the x-axis. So in other words, what are your y values doing? Are they going to be positive or negative for a certain value? So they're going to give us some certain criteria, and we're going to have to sketch a graph based off of what we have for this criteria. So I have this example here where it's a y-intercept at 0, -70. I have that it's going to be a linear function. I'm going to be positive for these values that x is less than -30. I'm decreasing for all my values, and then it shows me my end behavior. So the first thing I did is I went ahead and plotted my y-intercept. So on the y-axis, put a point at -70. Then what's going to happen is I look at my end behavior because that's going to show my tails. So as x is going positive, this is showing me that I'm going to end down. And as x is going negative, it's going to go up. So I know that my one on the left is going to be up and the one on the right is going to be down. Then it also tells me that it's going to be linear. So what I did was I went ahead and plotted the point -70 on the y-axis. I knew that my tails were going to go like this, but I didn't know if I had another point somewhere. And I did know that it said that the values of x are positive when I'm less than -30. So at -30, I knew is where I'm going to become positive above the y-axis. So that's how I put all those pieces together. You're going to pause the video and try the got it question. So in the got it question, you have a linear function. So that means I'm going to have a straight line. I'm going to have a y-intercept of 0, 0. My tails, it looks like I'm going to be going up on the right, and on the left, I'm going to be going down. So here's what I drew. I have my y-intercept at 0. My tail is going down on the left, up on the right, and also the x-intercept at 0 says it's going to become positive. So I know at this point is also where it's going to be increasing. Then what happens if it has a different kind of figure where it's not linear? So here's an example of where it's nonlinear. Same kind of scenario, but just giving you more information. So again, what I did was I started with my y-intercept and I put it at 3. I knew that it's continuous, it's positive for all of my values of x, and then it's decreasing at a certain point. I have a minimum at 0, 3. So if I have a minimum, that means that this is going to be at the bottom of my curve. My tails have to be facing up. So since everything is positive and I have to have a minimum, this is how I drew it. So this had to be at the bottom of my valley. My tails had to be facing up. All my y values are above 0, so that makes it work for everything. Pause the video and try the next got it question. Here's another nonlinear function. We see that we have a relative minimum at 1, -6, so I plotted that point here. Then we also know that our tails are both facing up because I have positive infinities. It's increasing from x greater than 1. So at 1 here, I know that I am going upwards, so that's how I drew that part. I know for values x such that x less than -3.5 is where it's going to become positive again. So here's an x-intercept at -3.5. Here's another x-intercept at 1.5. Now, the thing that kind of threw me off is that it said relative minimum. So I think that this would be the appropriate graph where this is a minimum, but you're going to have a lower hump down here somewhere before it reaches back up, only because they use the word relative minimum. Okay, Then the last example is just doing a real world example, but doing something similar where you're trying to make sense of it. So here's the scenario. Hay is test driving a car she is thinking of buying. She decides to accelerate to 60 miles per hour and then decelerate to a stop to test its acceleration and brakes. Takes her 15 seconds of uniform acceleration to reach her maximum speed and 15 seconds of deceleration to come to stop. Use the key features to sketch a graph. So it tells me that the y is the speed and that the x is the time. Okay? She decides to accelerate to 60 miles per hour and then decelerate to a stop. So that tells me that we are accelerating and then decelerating, so something like that. It takes her 15 seconds to accelerate to reach her maximum speed and 15 seconds to decelerate. So then what I did was I just put in my numbers. So I know my graph is going to look like this. Took me 15 seconds to get here, another 15 to finish. So that puts me at 30 seconds. And then I went ahead and labeled the maximum speed at 60. You're going to pause the video and try the very last one. On the very last one, here is your scenario. And this is what it should look like. So I'm starting at 0 miles per hour. I'm going to continue to jog until the 20th minute, and I'm going to go for 6 miles per hour. I'm going to keep that speed till the 35th minute, and then after that is when I'm going to decrease. So that's why I came back down and stopped at 40. All right, folks, that is it for sketching a graph. It's just putting all that vocabulary together.